Your home lab is a digital fortress, but what happens if you have accidentally logged yourself out? I'm Vasu, and that's the exact problem we are solving today. We have built this amazing self-hosted web services, but the moment we leave home, they are unreachable. And even worse, many of us are trapped behind something called CGNAT, which means our ISP won't let us open up any doors to the outside world. It's the ultimate home lab roadblock. In this video, we are building the master key, a single secure tunnel using WireGuard that gives you access to your entire home lab from anywhere in the world, completely bypassing any ISP restrictions. Now, you might be thinking, why not just use Tailscale or ZeroTier? And those are great tools, but I am assuming, like me, you are not sponsored by them. And more importantly, you believe in building and owning your own infrastructure. Building it yourself gives you the ultimate control, unmatched performance, and a deep understanding of how your network actually works. We are going to do this by creating a hub and spoke network. Using a tiny cloud server as a central meeting point, it's the most powerful way to connect all of your devices securely. This is the foundation of true sovereign home lab. Let's get started. I am here in my AWS console. First, we launch an EC2 instance. The key thing here is to select Amazon Linux 2 as the OS and T2 micro instance, which are free tier eligible. The most crucial step is the security group. This is our firewall. We need to allow two things: SSH access to configure it and a custom UDP port for WireGuard to listen on. The script we are using defaults to port 61517, so that's what I'll open up. Once the instance is running, we'll SSH into it. Now, for the magic, I've modified a fantastic installer script that automates the entire WireGuard server setup. First, we'll download it, then we'll make it executable, and finally run it with sudo. The script will install WireGuard, configure it, and ask us a few questions. It knows our public IP and it's already set up to create our first client, which we'll use for our home lab. The client is called Homelab 1, and that's it. Our WireGuard hub is now live. Time to connect our spokes. Let's start with the most important one, the home lab. Over in our home lab, we need a place for WireGuard to run. We'll use an LXC container for this. First, we give it a name. Let's name it WG Spoke. We'll set password, but for all other options like storage, CPU, RAM, we are just keeping the defaults. For networking, we'll configure the static IP address and the gateway. The container creation should be done now. Once it's running, there are two quick preparation steps. First, we can simply log into the LXC configuration file for our container and add this line. It's a single command from the Proxmox shell. This is what makes the network tunneling possible. Now here in the web UI, you can see that we have now access to the TUN device. Now let's go ahead and start the container. Once it's running, we'll log into the LXC container. Now let's go ahead and install the WireGuard tools. The installer script that we ran earlier created the configuration file for our home lab client. We just need to get it from the EC2 server. We can get that by getting the file and copying the contents. Along with it, we'll also need two other utilities, resolve-conf and IP tables, for our setup to work. Now let's enable the service and start the WireGuard up. To verify whether the connection is working or not, we can simply curl the IP info and verify that our exposed IP should be same as the public IP. Back on the EC2 server, I'm going to run the installer script one more time. This time I'll choose the option add a new client. I'll name it like, comment and subscribe. The script does its thing and we get a new config file. You know, that's a terrible name. I'm going to delete that and create a new client properly this time. Let's call it code unbound 1. The script runs again and we have the config file we'll actually use. The coolest way to get this on your phone is with a QR code. So I'll install a tool called QRN code. Then run one command to generate the QR code right away in the terminal. Now I just open the WireGuard app on my phone, hit the plus button and scan the code, and done. It's that easy. This is the moment of truth. The phone shows that we are on a cellular network, completely disconnected from our home Wi-Fi. Let's toggle on the WireGuard connection. First, let's visit the IP info and verify whether our connection to the hub is working or not. Here you can see that the location is California, which is where our EC2 server is located. So this seems to be working. Now let's try to access our image server, which is running at the local IP inside our home lab. And we can see it's not loading. There seems to be an issue. We have connected spokes to the hub, but we haven't told the hub how to connect the spokes to each other. Let's fix that. There are two parts to fixing this. First, we need to tell our home lab spoke that it's allowed to forward the traffic that isn't meant for it. We'll do this by enabling IP forwarding in the kernel and then adding a simple net rule using IP tables. This rule tells the container any traffic you get from the WireGuard interface, just send it out to the rest of the local network. For the real setup, you would want to make these IP table rules persistent across reboots using a tool like IP tables persistent. Second, we need to tell the WireGuard hub which IP addresses are accessible behind our Homelab spoke. We'll edit the WireGuard configuration file on the hub. In allowed IPs, we are going to add our entire Homelab subnet, which is 192.168.2.0/24. Now we restart the WireGuard service on hub. Now we'll test if our hub can actually reach a device inside our Homelab. From our EC2 hub, let's try to call the image server. Still not working. This can happen sometimes with networking changes. Let's quickly jump to our Homelab spoke and confirm it still has outside connectivity. The spoke itself is working fine. Sometimes it just takes a moment for the routes to fully propagate. Let's try that curl from our hub one more time. There we go. We are now successfully routing traffic from the hub through the WireGuard tunnel and into our Homelab network. Alright, back to the phone. WireGuard is retoggled. Let's try to access image again. And we are in. Full access. We can now log in and see the photos we uploaded in the last video, all while being on the completely separate cellular network. This is the power of true hub and spoke VPN. We have our own private VPN, secure network that connects all our devices and network together no matter where they are. So there you have it, a powerful, secure, private network for your Homelab and all your devices that gets around any ISP limitations. We have full, secure access to everything in our Homelab from anywhere in the world. But you saw that I had to manually run a script to add my phone, and that's not very lazy of me. What if we could automate that? What if we could have a web page that you just type your name, hit a button, and it automatically generates a new VPN config and emails it to you? That's exactly what we are going to do in the next video. We are going to take the setup, plug it into NA10 to build a fully automated on-demand client provisioning system. It's the next step in building a truly self-managing Homelab. Make sure you are subscribed so you don't miss it. Thanks for watching Code Unbound, and I'll see you in the next one.